Good, good. Great, yes. So I'm Richard Brown, the technical lead for the SLE department, working in QA. So, the SLE QA department, and also the openSUSE chairman. And I'm here to talk to you about openQA and how we use it in SLE. And now my boss is here, so I can really start. So the contents for this session is why, to start with why SUSE automate testing. What are the sort of the more broader impacts in the communities and the projects we're dealing with, and how that then impacts the products we're working with. How we looked at lots of other testing tools and the other ones out there, the things you might be already using in your environments, and sort of the issues we have when we're dealing with SUSE's products and those testing tools. How openQA solves most, if not all, of those problems for us. Then talking about who's using it, and then eventually how we're using it specifically for testing SUSE Linux Enterprise. So, why do we automate testing? The first and foremost part of it is really a case of dealing with change. We're always releasing new products. We're always, adding new service packs to our products, adding new features to our products, and obviously new products from the ground up. And all of this change is something that desperately needs to be tested, especially when you then think about actually what our products contain. And in most of our cases, we're dealing with various other upstream projects. Part of, in the case of SLE, obviously you've got things like kernel, GNOME, Docker, SaltStack, all there. And of course, when it comes to a new service pack or a new release, there's at least a consideration about do we include the latest new upstream version, or at least we have to be aware of what the upstream is doing, what features they're doing in there, what functions, what customers want more from there. But all these projects are moving faster and faster and faster. You can see here the kernel has a new version every 3 months, GNOME every 6 months, Docker every 3 months as well, and SaltStack every 3 or 6 months, depending on which side of the releases you're on. So, that's great, right? I mean, that's how we get those security bug and performance fixes into the product. That's how we get the new hardware support into the products. That's where we get those new features, besides the ones we're developing ourselves inside SUSE, of course. But that's also where all the risks and the negative issues come from as well. I mean, it's by introducing these new things, these new factors, that we start getting security and performance regressions. It's where bugs come from. And it's also where functionality changes come from. It might work, but it might not work in the way you expected based on the previous version. And so, all of this is, a never-ending saga when you're dealing with upstreams. And also, we've been looking at sort of how users' expectations are when it comes to using software. And this is a sort of a general term, but it applies in particular for the SLE family of products. Customers are expecting things faster. That's why we have the SLE modules, and also why we have Package Hub for faster and broader, covering things that we typically couldn't put in enterprise code base, but we want to put inside Package Hub. And then, outside of the enterprise space, you've got things like rolling releases, like openSUSE Tumbleweed and Arch. And you've got obviously options like the build service and Copor and AUR and EPEL, where you're getting effectively third-party software from another source. It might be moving quicker. How do you make sure the base system that's running on is stable, is working, is how it's meant to be? And so, when you then look at sort of users' expectations, also how they're actually consuming that software is getting more and more diverse. It's not just a simple operating system and a distribution sitting on a bit of physical hardware anymore. Obviously, virtualization's everywhere. Containers are growing in everywhere. Modularization, both in the sense of the SLE modules, but in just consuming software in smaller chunks as part of containers, as part of Snappy, Flatpak, all of that kind of stuff. And you see that sort of being solved in various different ways, as different editions of operating systems, or even as totally different distributions, all sharing the same code base, like you see with the SLE family, with SLES and SLED and SLE for SAP, and openSUSE Leap, which of course contains the SLE code base. And all of this makes things very, very complicated ultimately. And inside SUSE, we really embrace this kind of concept that we're using when we're building our stuff, and also we see our customers using more and more, sort of DevOps for distributions. We think in these terms of, we plan everything before we do it. We're coding all the time, we're building all the time, we're testing all the time. That testing might also include our beta customers. Then obviously we're releasing it, and we're actively seeking that feedback once it's deployed, and then monitoring it, looking at what's being needed in in maintenance updates and stuff like that to then plan in and factor in with everything else that we're doing as part of our distribution. And that's great and wonderful, but you take this concept and all those other issues that I was talking about, and I'm the poor guy who's having to help design the technical test plans for SLE, and my test plan diagrams start looking like this. Because there are millions of different factors, all interconnected, all that we all have to worry about, and we need to make sure this all works together. And at this point, I've been to lots of developer conferences, and I talk about this, and someone always comes along and says, "This is fun. We've solved this problem. There's tools already that can do all of this. There's Gerrit, there's Selenium, there's just use everything in containers. It'll be fine. Jenkins, Travis, whatever." And then, of course, somebody mentions Docker, and then somebody else mentions Docker, and somebody else mentions Docker, and yeah, you get the idea. And for developers, this is great. Pure play developers, developing code, using these tools, no question about it. These tools really solve developers' problems at the end of code. But we're SUSE, and we don't actually build code mostly. We do, but we're building it as part of products, as part of distributions. SUSE OpenStack Cloud is an OpenStack distribution, taking our stuff and everything else the upstream has done too. Same with SLE, same for SLE for SAP. Every product we do has this sort of broader long tail of code that we didn't write that we have to worry about. And so if we're only using tools like this, looking at the little bits that we're actually actively coding, that's not actually what you're going to be running in production when you're using it as a customer. So we're really, and ultimately you don't care if our part works, you care if the entire stack that we've sold you works. And this is a problem that we sort of have with these traditional testing tools, is they're great at looking at the code, but they don't look at the entire application or the entire software stack as a cohesive product. Until now, because we have openQA. So openQA started in 2009, originally in the openSUSE project as a open source distribution testing framework. It's now much more of a operating system testing framework or a universal system testing framework. And it tests the operating systems and their applications. And there's no distinguishing what it's testing from the openQA perspective. So it can test graphical stuff, it can test console stuff, and the main users of it at the moment are openSUSE, using it for both testing Leap and Tumbleweed, SLE for testing the SLE family of products, and Fedora for testing Fedora. So yes, even Red Hat are using this, which is really fun to be able to say. But so the kind of first point when I'm talking about openQA to kind of sort of lay the groundwork is it tests like a user. This is not a testing tool that needs to be language aware or API aware, digging into your code that you're writing and knowing how to interrogate that. It's actually going to use that software the same way a user is going to do it. It controls the keyboard and the mouse the same way a user does. It's going to want to do the same workflows that you would instruct a user to do. And we use, for the graphical side of things, openCV to actually have screen output compared to predefined needles, which is our term for reference screenshots, where we've taken a screenshot of what we're expecting. We've actually declared the areas of interest that we're working on, and that's what we're comparing against. But if we're not doing the graphical stuff, obviously, plain text from serial, command line stuff is great. That's, it's way easier to write those tests. But it's not that hard to do the graphical stuff either. So this is taken from openSUSE Leap. And this is a typical needle where we're making sure that the GNOME desktop, in this case, is being selected for installation. And that little square box there is the only part of that whole screen that openQA cares about. That test is just making sure that the GNOME desktop is there and has that little green dot in it that has been selected. So our software designers can do whatever they want to the rest of that screen. They can change the text at the top, they can change the banner, they can change the theme. As long as they don't change the background color and the font, openQA won't even notice. If they do change it, it does fine. But they can also change the location as well, and openQA will then actually find where the image is moved. It takes a little bit more processing power, but it does mean that you don't have to rewrite your tests anytime one tiny little thing's tweaked in your graphics. But like I said, not just graphical testing. So with openQA, we have all the tests written in a domain-specific language, which is Perl-based. So you can just write your tests straight into that, do it natively that way. Also, if you want, and you have existing scripts you want to work in any language at all, Python, Perl, whatever, Bash, you can write into the openQA test suite. openQA has APIs which will then download it to the machine and run it on the machine, and then take the results from that. And you can also sort of do weird and wonderful other things, and basically anything you can describe to a user. So if you want to do something a little bit off the wall, like connect to some external service and make sure that works, that's fully supported inside there as well. When it comes to the actual results from a console thing, obviously command line stuff, we're going to do simple string comparison, but we also have full support for parsing JUnit files. So if you have existing test suites that pump out a JUnit response, openQA will then use that as part of its reporting as well. Or you can do very fancy stuff inside the openQA domain-specific language to kind of meld in your own analysis. So, do some test result, pump out some ridiculous XML file and teach openQA how to understand that, and then add that to the results of openQA. But an incredibly simple console example is something like this. So this is a simple 4-line one that starts by picking the root console. In our case, we've abstracted the various different consoles because of different architectures. So, this will normally be TTY2 on an Intel machine, but on a S390, that's actually going to be an SSH connection that's already logged into root. But openQA doesn't care about that. We just tell it, give me a root console. So at this point, it knows it's root. We then run a command to install a package. We then run that. Well, we use curl to pull down an example file to make sure that it's working, and then we just validate that that tool, A2PS, correctly works. Job done. So we make sure that A2PS is constantly working. So if there's one thing you take from this, because when we talk about openQA, we normally kind of linger on the whole graphical stuff. openQA does not just test graphically. It can do whatever you want on the command line side of things. It just doesn't look as nice in slide decks, so I end up with quite a lot of pictures later on in this when I'm talking about the graphical stuff. Of course, no point testing if you can't actually see the results and the reports of what you've actually achieved in that testing. So each test result, each test scenario has a full set of screenshots of everything it's been doing while it's been going along. Even if you're not using them for the analysis, it'll take the screenshots anyway, just so you can see something in the web UI and get a feel for what's going on, as well as logs, which you can then download and parse at will. We also record videos of each run, so if something weird and wonderful happens that openQA isn't expecting, you can very easily just pop to the video and actually see exactly what was going on the system at that time. We have the automatic saving of ISO files and hard disk images for any reproduction. So the ISOs that openQA uses when it's testing an operating system, or the disk images openQA is using, are all kept in openQA for download and reproduction. And you can also instruct openQA to actually save an image at the end of a test run or as part of a test run. So you can use it to generate your disk images for testing and all that kind of stuff. And then we put all of the results of this in one nice big dashboard for review and reporting, which for openSUSE looks something like this. So we actually can split up the test scenarios into various different job groups. We inside SUSE, we align them based on the type of testing and the teams involved in reviewing it. In the case of openSUSE, it's slightly more split on sort of where the packages are coming from. So Leap 42.1 maintenance had its own job group, and you can see there the results for every single maintenance update going to the openSUSE project. In addition to the actual maintenance updates, openSUSE has a collection of all of the updates currently in the channel waiting to be tested or waiting to be released, so collectively. And openQA can actually test all of those in one go. So as well as individually testing one maintenance update on top of the base system, we can test all of the maintenance updates that are currently waiting to go out, which sometimes it comes up with nice wonderful issues. If both maintenance updates work fine until you ship them both at the same time and they break each other, so that's why that exists. We also have the actual updates that have been released, and this was taken at a very embarrassing time when we'd actually released a bad update. And then you can see openSUSE Tumbleweed, the rolling release, where we're not actually doing updates at that point. We're doing the entire distribution in a rolling fashion. And that's tested all the same way as well. Drilling down to any one of these buttons on the side, or the links on the side, takes you to a dashboard where you can see all the individual scenarios that openQA has run and their individual status. And we split this by architecture. openQA actually supports all the architectures that the SUSE and SLE family products support. So 64-bit ARM, 64-bit Power, 64-bit Intel, and S390X. And I'm missing one. No. Oh, on openSUSE we also support 32-bit. That's it. I am missing one. But this is SLE now that I'm showing here. And you can see all the different scenarios running all of that. Obviously, not all scenarios make sense on all platforms. You're not exactly likely to use software RAID on a mainframe with a DAS-D, so we don't test that. But you can see, what the status is when a test has failed. Such as over there, you can actually see at which point in the test suite did it fail. And I somehow skipped ahead when I didn't mean to do that. And yeah, we have obviously typical colors, green, red, and the yellow-orange there is for the openQA concept of soft fails, which are an issue which openQA has detected and is considered a failure, but openQA can work around it. So you can easily write a test script that, find this problem. If you find it, do this other thing, and then carry on testing. So you don't, a lot of automation tools have this problem of, they hit the first issue and that's it. They're stuck, they're frozen, and you can't do any further testing until you've seen the whole thing. So openQA, we have soft failures for working around that. Clicking on any one of these single scenarios gives you the detail of that scenario, and you can see all the individual test modules that openQA has run through. In this case, it's an installation, so it started by checking the disk size was correct, booting the installer up, and running through a basic YAS installation. Now, when something goes wrong, which unfortunately here it didn't, if it's a case of sort of the graphical comparison failing, you end up with a screen of the web UI that looks a bit like this, where you see the screenshot of what the system was at the time, with a big red box around it. This is actually a graphical visual diff, so we can then analyze exactly why the thing went wrong. And there's a yellow bar on the side here, which you can click on your mouse and drag along, and it will do a side-by-side comparison of what it saw alongside what it was expecting, the needle, the actual reference screenshot. So in this case, what openQA saw in this example was openSUSE Leap 42.2 alpha, but what openQA actually saw when it was, what it saw was 42 alpha, but what it was actually expecting was Tumbleweed, because I was actually running this in a Tumbleweed openQA test run and just using it to produce a demo. So you can very easily see sorry about that. Exactly where a graphical problem's where something's snipped in. openQA will even do its best to find sort of a similar match, and hence the overlapping here. And then you can use the visual diff to see exactly what went wrong. So if you're doing any sort of UI testing, this is a really easy way of finding out exactly where that problem's come from. Back to the non-graphical stuff, though, you've got the video, the logs. You have logs actually from the openQA system itself, so that's sort of the internals of what the test system did. And then from openQA, you can actually arbitrarily upload any logs from the system under test to the openQA system, which are then stored and attached to the job, so you don't have to worry about digging them out later on. And all of the assets that openQA used, all of the ISOs, all the disk images are all stored there, ready for you to download as well. The architecture of openQA is based, in design very similar to how OBS works. So we've got the main openQA web application server, which has the database attached to it. It can be SQLite, it can be Postgres, it can be pretty much whatever you want. And that's sort of the main heart scheduler server for openQA. On the same machine or separate from that, we then have worker servers, which are running one or more instances of the openQA worker service. It's a systemd service, so you can just instantiate as many of them as you want. And those are then communicating back to the web application server using, well, WebSockets REST and NFS for the file storage at the moment. We're planning on adding Ceph support soon. And then as you schedule jobs on openQA, the worker then picks up those jobs, receives a whole bunch of variables and such from the database, so it knows exactly what it's being told to do. And from there, openQA will then run OS autoinst, which is effectively the test runner. We'll take the tests from your test library and actually start running through them. And depending on which backend you use, which I'll talk about in a minute, OS autoinst will then be actually firing up the VMs or connecting to your system under test and then actually running those tests on that hardware or on that VM. So we've got support for multiple different backends. The QEMU backend is the default one we use, so we're using KVM most of the time and doing lots and lots of testing in VMs. We use QEMU in particular because it's designed to be very, very useful at emulating actual real hardware. So we use it to tweak a lot of variables and test things like multipass and other stuff, which you could do in a physical environment, but you can't do in, let's say, a libvirt virtual environment because libvirt doesn't have the support for all those tweakings and tunings. But we do have a libvirt backend as well. So if you have something like VMware or Xen running on a different libvirt machine, openQA can SSH to that and run its tests there, just with a subset of the full functional of what hardware can you emulate on it. And because virtual machines are great, but they're not real machines. We also have two options for testing on real hardware: the IPMI backend, where we can talk to any Supermicro IPMI machine with full graphical support, or any IPMI machine without graphical support, and actually start up the machine, control it, deal with the serial console. Or the general hardware backend, where you basically just feed openQA a command to get to the serial console. So that might be IPMI, it might be something else. And then if you're using the graphical side of things, the command you would use to connect to the VNC or graphical output of that, and then openQA will just connect those two things, and you can connect to pretty much any hardware or IP KVM device or that kind of thing to drive your testing that way. So yeah, that's pretty much everything I just said there. So yeah, we're using VNC and serial for the QEMU backend. We're using VNC and SSH for the libvirt backend. And for the IPMI ones, we're using VNC, serial over LAN, IPMI, kind of whatever you need there. openQA has been under really heavy development over the last couple of years, and sort of the main areas of development that are fun to talk about at the moment is we've added multi-arch support. So back in 2009, we were doing just Intel. Now we've got the whole gamut of architectures under there. We also have support for multi-machine testing. So if you have, let's say, a scenario which actually composed of multiple scenarios. So you want to test, for example, a 3-node cluster: node 1, node 1, node 1, node 2, node 3. openQA can schedule all of those and set up the Open vSwitch environment it needs to actually network those different VMs together to then be talking to each other, isolated from everything else on your network because you don't want them breaking that, and then run those tests against there. And we've also got a lock API, so you can actually orchestrate, okay, this test has to get to this point, this test has to get here, then you can start testing between the two, because there's no point doing client-to-server testing if only your client started up. So we've got full support for all of that. Back when openSUSE started with it, they didn't have to worry about things like add-on products, because there's just openSUSE. Whereas, of course, with SLE, we have different add-on DVDs and different add-on channels and SEC and all of that stuff. So we've added all support for that, of extensions, modules, and the idea of sort of a product consisting of multiple media. We've added real hardware testing. The disk image creation, so all that stuff I mentioned about, as it does a test, it can actually save that disk image. And we've also looped that round, so openQA tests can use a disk image from other openQA tests. So you can do sort of one phase of testing, get it to a certain point, have that generate a disk image, which is then your trigger point for your next set of testing, which is using that disk image for doing other deeper stuff. So you don't necessarily have to waste time doing sort of in-depth testing on a product that can't even install, for example. Multiple hypervisors, including KVM, Xen, VMware, KVM for System-Z, Hyper-V, Power KVM, and Fedora added Fed message support, which is their 0MQ message bus system, and they use that for sort of orchestrating a lot of their stuff on their infrastructure, very Salt-esque, so it's very similar. You can just sort of put something on the message bus of, I want to start testing this. openQA will consume that and then start testing accordingly.
Can I ask, is it also including ZVM?
Yes, it is including ZVM, and for some reason I forgot to put that on the slide. Yeah, it actually natively will talk to ZVM over X3270 and do all of that stuff through that. So yeah. We've also added a sort of a review workflow. So having the results is great, but when you're especially dealing with a product that's moving very, very, very quickly, you might be producing lots and lots of builds, and you want to have an idea of, okay, where is this failure coming from? Is it a problem with the automation? It sometimes happens. Is it a problem with the test? Or is it a bona fide bug in the product? So we've started tagging everything. The issues on the dashboard, you can actually tag it, mark it with a bug ID. It's aware about Bugzilla and most of the other short codes which the openSUSE and SUSE products use. So it then can actually link directly to that bug tracker, and you can see, okay, that failure caused by that bug. And of course, openQA is aware of all of its previous results. So if it's failing at the same point, the same time, over and over and over again, it'll automatically inherit that tag. So you can actually use it to track, okay, this started 4 months ago and it's still happening 4 months later. And we've recently tuned the algorithm so it actually can track intermittent issues as well. So, have an issue, you fixed it, great. 10 days later it regressed. Yeah, openQA will be there to remind you, which is really annoying when it happens, but very useful because you're not then wasting time reanalyzing what you already know about. And also then, that's testing the individual results of an individual scenario, but what about the entire build? So, if you're following like a waterfall model, you've got all your builds. One of these is going to be a beta, one of these is going to be a GMC, so we've got tagging for that as well. And when openQA, of course, is doing an awful lot of stuff, there's an awful lot of disks and data and storage. We have a cleanup for tidying up your data store. You don't want to be deleting the data, your nice, important GMC builds, which management might ask about the week later. So you can tag a build to save it from being obsoleted and being deleted. So this is the screen I showed earlier, and over on the left-hand side, or the right-hand side there, you can see the little lightning bolts, which are the tags to show that, in fact, those two problems were caused by issues with the ZVM backend we had at the time, where it was misbehaving. So we flagged it with the lightning bolt, which is an automation failure. And on the far left, on the far right, you've got an installation failure there with a bona fide bug, which actually links straight back to the bug in bugzilla.suse.com. So, who's using openQA? Like I already said, openSUSE is using it for their rolling release, where it's really an integral part of the entire distribution. openSUSE is producing new versions of Tumbleweed 4 or 5 times a week, as if it's an entire distribution. openQA is the only QA that can do that at that pace constantly. For Leap, it's also used for validation and system testing, the basics, making sure that it's good enough to then become a beta or a release candidate for humans to start testing it as well. In SUSE, we're using it for SLES, SLED, and HA at pretty much all stages of the development process now. So at validation, when we're just making sure that it's good enough to then start giving it out to customers and partners. We're using it for full-blown system testing, for stress testing, for regressions. And we're just now also adding maintenance testing as well. So the maintenance updates that customers are receiving are now being tested in openQA before they go out to customers. And like I mentioned, multi-machine testing, and yes, Red Hat are using it as well. Red Hat have been using it since Fedora 22. They actually Dockerized openQA, so you can run openQA in a Docker container for the scheduler side of things and all of the workers. They originally did it because they weren't allowed to run SUSE or openSUSE in their data center at Red Hat, but they were allowed to run it in a Docker container, running SUSE, which was weird. But yeah, they giving an awful lot of stuff to us back in patches, ideas, tooling, like the Fed message stuff. And you can see their public instance for all the Fedora testing on openQA fedoraproject.com. Tumbleweed, like I've already said, it's an integral part, moving incredibly quickly. And this says 2 or 3 days, but in fact, Tumbleweed updates now are pretty much happening daily. 2 days is normally when things are getting quite slow. And to kind of give a taste of the pace of change that Tumbleweed is dealing with, every week one of our Tumbleweed maintainers does a report of how much has been done by the community in that week in the Tumbleweed product. And he said it was a quiet week one week. We only did 3 releases. There was only 146 package updates and a whole new kernel and a whole shuffling around of stuff on the DVD. And that's what sort of openQA and Tumbleweed now considers as quiet, which is kind of crazy really when you think about it. That's more than 146 maintenance updates for SLE almost. In fact, earlier in the year, this is more what a typical Tumbleweed week is now like. So 5 updates, a whole new distribution, new ISOs, new repositories, 370 new packages, a whole new version of the GNOME stack. In fact, this is when Tumbleweed was merging the version of the GNOME 320 GNOME stack, which is now in SLE 12 SP2. And that was it being merged less than a week after its upstream release. So straight from upstream, straight in there, done, with 118 different tests. And then we did it again a few months later. So the pace doesn't change, it keeps on doing it, and yeah. In fact, we did GNOME 322 less than 48 hours after the upstream release. So yes, it's always changing. openQA is always there with it. But openSUSE Leap kind of comes on and gives a bit of a unique twist to the whole thing. Because the openSUSE Leap distribution isn't a pure distribution in the sense of the old openSUSE distros. It's based on SLE 12. It's got the SLE 12 codebase in there as its starting point, and then community stuff building on top of it. So you effectively have 2 completely different code bases that you're then having to merge together to make a consistent distribution. And so openQA is there during that entire development process for Leap, making sure that sort of the Tumbleweed side is working well, the Leap side is working well, the SLE side is working well, and then mixed it all together that it produces one cohesive product. So every time we're doing any integration work there, any update happens to SLES, Tumbleweed, whatever, again, new build happens in SLES, and my slides are changing themselves, which is quite nice. And yeah, and you end up with what you have there. So the whole SLE openSUSE family is all now tested in openQA. You have the shared code base, which Leap and SLE use. You have all of the community packages that Leap is using. You have the whole of Tumbleweed, all consistently tested with one testing tool. And in fact, one set of test suites. So we share all the same test suites. So as we're developing new tests for SLE, they're also testing Tumbleweed. If we're testing new stuff for Tumbleweed, they're also available for testing SLE. So specifically about SLE, we started using it around about the time of SLE 11 SP4. So after SLE 12, but about when SLE 11 SP4 was around. At that time, we were just dealing with what we call validation, which I'll go into in more details. And then since then, we've been expanding it across the whole range of SLE QA stages. And in fact, it's kind of stretching now beyond QA. We have development teams using openQA testing before they even submit something, and release managers who are adopting it as part of their check-in and review process before they accept something for us to test. So it's kind of spreading beyond the borders of just traditional QA. And so it's doing, the pre-validation testing before something gets put into the product, the validation testing, and afterwards. So the typical development process for a single package in SLE goes through something like this. So, we have a developer, we have a package. They're going to submit it using the build service. That's then going to go into what we call a build. Yes, sir?
Do you have also some numbers how often we test the SP2? If you have them, don't tell them.
I don't have them, but you do.
So for me, I only have the numbers of RC3, which is the latest numbers, the latest build before our Goldmaster candidate. We had quite some builds with Goldmaster candidates. But what do you guess? How many test runs openQA did on /12 SP2 over all architectures? Anybody?
That's 6 months of development. And you've seen the betas of the release candidates.
250,000 over all architectures. Even on ARM, which is a new architecture for us, and ARM getting really data center hardware is not that easy. Even on ARM, we had nearly 20,000 installations. So openQA is doing a lot for you, and we do also some manual testing.
Yeah, I'm getting to that part as well. So package submission goes into a build. At that point, We then test the entire build, validate it. When those builds are approaching a milestone, such as an alpha or a beta, that validation is what defines that build is going to be the alpha or the beta that we then ship to customers. That's what we call it, a milestone. So we do a little bit more testing at that point. And then ultimately, at the end of the release process, we ship a product. So in openQA, we kind of call these various different stages different things. So when the release managers are looking at it before the build, we call that process staging. When QA are looking at it before it becomes a milestone, we call it validation. And then all the kind of additional testing after that, looking into performance regressions, extra deep diving into virtualization and stuff like that, that's typically done sort of post-validation because it takes weeks. So staging, every single submission for SLE gets tested in staging before it even gets accepted into the code base. So basically this is using sort of a bit of OBS magic where we, in essence, do a what-if distribution. We take the SLE code base as it is right there, take that one change and make up an entire distribution with ISOs and everything as if we'd already merged it. And then we throw that to openQA and run a few smoke tests, a quick test on that and make sure, okay, this isn't going to set the whole thing on fire, at least it's safe enough to check in. So that gets monitored about hourly by release managers, or in fact less than hourly by release managers. And that's how we get incredibly quick feedback to our developers that it's good or it's bad. And it's also how we get the code base of SLE moving incredibly quickly compared to the old-fashioned way of doing things, because we can be a bit more risky than we used to be. We know it's not going to break because we've already tested it in staging. Yeah.
On per package basis?
Yes, on a per package basis. Yeah. This actually was borrowed from Tumbleweed, so it scales. Tumbleweed is a bigger code base than SLE. They do the same there. In the case of Tumbleweed, they don't do it on every single package because it would be a bit crazy. But SLE, every single package submission goes through staging, doesn't it? Yes, good. He does it. So once we have a build, we then have a much deeper, broader validation test. It's about 120 scenarios now, but that's constantly increasing and decreasing and merging depending on what we're interested in for that product. And that is done in parallel. So the scheduler receives that new build. It will spin up as many tests as it can in parallel across our test farm, which you heard the actual numbers of 250,000 at the end. That we only have about 12 machines, physical machines, doing all this testing. So that's 12 machines running incredibly hot for quite a long while. But each one's running about, on average, 10 to 16 workers on there. So it adds up, runs very well, runs very, very nicely. And it also means we can start getting feedback very, very quickly. You might not get the full results for 4 or 5 hours, but you can see very, very quickly, okay, this is going in the right direction. Everything's starting to flip to green. And that's why now with milestones, we only release a milestone once we've tested it in openQA and everything is sufficiently green for that stage. Obviously, during an alpha, we're probably going to be a little bit more permissive about the odd failure. During a beta, we're going to really not start wanting any failures in there. And obviously, release candidates, we start getting really grumpy. And that's why sometimes you see a release candidate take a little bit longer to come out of SUSE because openQA is there checking that it's good enough at that point. And compared to manual testing, because we used to have this process with manual when we were doing pure things in manual testing, but it didn't scale in nearly the same way. So we had the same test coverage, but you only have a certain number of engineers. So our only option was to carve up that test coverage and have each engineer do 4 or 5 scenarios themselves at each milestone, and then every different milestone flip which ones they're doing. So by the time you finish the entire product, you've at least looked at every scenario you care about once. With openQA, we can look at every scenario we care about once a day, twice a day, 3 times a day. So it's really changed the coverage and the performance we have of being able to say, okay, these scenarios work. We know they've worked. We can see the installations. We can see the setups actually working all the time. And then when the odd regression pops in, we know exactly where it came in, which check-in, which build, which makes it incredibly easy to then go, okay, that's what caused it. Let's take it out, move on. But that's kind of the main sort of functionality testing, making sure the product actually works. After that, we have post-validation, so things like kernel testing, regression testing. The LTP suite now all runs inside openQA, so we're doing the whole in-depth checks of kernel syscalls, kernel functionality, stuff like that. And even sort of some performance and virtualization based on real hardware testing of connecting to those IPMI of those machines, setting up virtual machine environments, testing that the hosts work, testing that the guests work, so on and so forth. These can take hours or days compared to the validation, which typically is minutes or hours. But of course, gives us a nice, constant, ongoing picture of where the quality of the product is as we're moving along, without humans having to look at it constantly all the day. And then also maintenance updates. In the case of maintenance updates, there's sort of three main groups of interest for SUSE. Obviously, the incident testing. This one maintenance update fixes this one bug, making sure that doesn't invalidate the system, making sure the basics still work, making sure the basic functionality still works. And if we have a test suite for that particular package, making sure that works according to spec. We also have a broader set of tests against existing known good openQA tests. So we can do stuff even before the release, like we're doing now with SP2, with SP2, where last week before we released SP2, we were already testing the first maintenance updates before the announcement was released, making sure that the distribution still worked. The first updates we're going to be pumping out soon aren't breaking anything. And one area where things were incredibly tricky for manual testing was live patching. Because the SUSE live patching product in particular, you've got many different supported starting points for live patching, because every live patching point is taken from a non-live patching kernel point. And I think we support something like 4 or 5 different threads in parallel of which kernel version you started with, live patching from there, and then we expect you to hop to the next version within 6 months or whatever. That is a perfect example of that crazy testing matrix I saw. It's an absolute nightmare for our maintenance team to do. They used to be doing it all manually. It would therefore typically take them about a week to get all of those scenarios out the way to make sure that a live patch works. Well, it's a live patch. We want to do it quickly. It's dealing with security updates. A week was not fast enough. openQA does exactly the same test coverage, totally automated in about 2 hours. What used to take a week. So it's just like for like, taking the same test suites that we were doing manually, putting them all in openQA, splitting it across many machines, running it all in parallel. So the main benefits that we're seeing, doing this for the last few years, is major breaking changes just aren't hitting the SLE code base easily anymore. Staging catches them. If staging doesn't catch them, validation catches them. If that doesn't catch it, it's going to get there in the end. So, it's very, very hard to get a major issue appearing in there. The ones that do get in there, because it's not perfect, become the new test cases. So ideally, we only make the same mistake once. And beta customer feedback is even more important now than it used to be, because that's what I'm using in particular for really sort of informing me what needs to be covered in this, what bits are we missing, what scenarios matter to you. But at the same time, actually, that's proving one of the flip sides, because we've also got this issue now of our beta customers seem to be way more bored than they used to be. When we started this with 11 SP4, the beta mailing list was full of stuff and lots of ideas that we needed of stuff we were missing. Then for SLE 12 SP1, well, by that point I'd implemented about half of them and it got a bit quieter. SP2's been really quiet. It's just, we know there's more testers than before. The public beta has been huge and there's been lots of downloads, but it's really quiet. So I'm there, I'm listening. Please put your stuff on the beta mailing list because we will start using it for testing. But it's one of the positives, I guess, that we have bored beta customers, but it does make my life a little bit harder. But it also means that on release, we're seeing less bugs, which of course is the whole point. The product's meant to work better. And we're also capable of doing an awful lot of more changes to SLE a lot faster than we were able to. So, things that we used to think of, there's no way we can do that. It would be a lovely idea, but there just isn't enough time to, test that. We can develop it, but can we actually test it and make sure it works? And so we say we don't, and then we'll put it in another service pack or in the future. Because we can get these quick turnaround times, get a much better idea of what's going around, we sometimes will just invest the time to try it, see how it works, and then, suddenly it's now in there, it's a feature, let's stick with it. So, which then means innovations get to customers better, which is also part of the point. So if you would like to know more, the main website for openQA is open.qa. And there we have all the documentation, we have guides on how to install it, we also have links to our test suites where you can actually see the test suites we're already running. They're all in GitHub, you can actually contribute to them directly, so if you want to write your own test suites and send them to us, we will then start testing openSUSE and SLE using them. And we also have a feature and bug tracker for bugs in openQA and sort of feature requests if you're playing around with it, but we just haven't got the enablement for some very complicated scenario. We want to hear about it, we want to consider it, because it's probably going to be something we're going to be having to do internally anyway at some point. So we want it on our radar. And with that, I am done. Are there any questions? Yes.
How would I, as an application developer, use this? Let's say we have a project.
Yep.
We are on the build service. How do I get started?
So if you're an application developer wanting to use it to get started, which platforms does your application run on would be the first question I would ask.
x86, 64 for
And which operating systems?
Yeah, SLE and Leap.
SLE and Leap. So because openQA supports booting from a disk image, you would need a SLE and disk image sort of reference host to start with. So just start with that. Write a very simple test suite that, it's a one-liner. You can copy that from openSUSE of booting the image up, and then installing and starting your application on that system.
Okay. So it's capable of adding the OBS project as a package installation source and downloading packages and things like that?
Yeah, well, anything you can describe to a user. So in a case like that, you'd boot the system up, then have a test suite that does the adding of the OBS project and installation, which of course you can make sure that's still working, and then from that point on, load up your application and run it along. So it's very easy to bootstrap that stuff. That's actually how we test modules before the modules have ended up in the SEC system, for example. We connect to the build service and do the same thing.
And a follow-up question, do you have some kind of a repository or a library of common routines, test routines or snippets?
All of the test routines we are using for SUSE and openSUSE are all open. So there's no common repo, you can just grab them all from there. Fedoras are all open as well. And we do have a few sort of simple examples and other ones, because the SUSE/openSUSE one has become this sort of massive beast where I can come up with lots of nice simple examples, but I can come up with some really complicated ones as well. Yes?
Could you come up with some examples for complicated tests? Or with some examples for tests that you cannot do?
Okay, I'll come up with an example of tests that we couldn't do 2 weeks ago, which would be something like a 5 or 6 node HA cluster. Because that, we had all the enablement of multiple machine testing and, open vSwitch connecting everything together. But the problem we had there was really orchestrating the various different sort of interaction points in the tests, of getting all the nodes to the level they needed to be, and then moving sort of the tests on node 1 forward when node 2 was ready and stuff like that. That was mainly because the test API was sort of using a very mutex orientated approach. So you had to be you had to think multi-threaded to figure out, okay, this is here, therefore I can unlock that, and it was crazy. It made sense for 3 nodes, but after that it went nuts. Since then, we've changed the entire API, ripped all that out, and replaced it with barriers. So it's a much simpler model than of get your nodes to where you want them to be, unlock everything, you're gone. So that was the trickiest one that we've really had a hard time. The other one that is a sort of perennial battle, and I don't think it'll ever stop, is real hardware sucks. So all the real hardware testing, we've got the capability for it, it's great, but like our IPMI machines, the amount of times we hit like weird BIOS issues and the poor machine's rebooted for the 50th time of the day and it's just stuck there at the BIOS. We're like, yeah, great. I mean, we do our best to teach openQA how to work on that remotely, but we don't really like power cycling all the machines every single time. That's not going to be too good for the long-term life when you're doing tens of thousands of tests. So I don't have a great answer for that one apart from be really careful about which hardware you buy. Yes?
Can we add the new backend?
Yep, no problem. So what kind of backend would you be interested in?
Because we have a homemade tool to install virtual machines. So
yep.
we use XM command tools or VRSH through different scripts.
Yep.
And it could be interesting to test this script with openQA.
If you're using Versh, the libvirt backend is actually quite lightweight. Then you might just be able to plug it into that without having to worry about doing it.
But we use Excel command, but in custom script.
Okay.
And this custom script needs to be a test.
Yep.
And openQA can be useful for this.
Yeah, that's shouldn't be a problem at all. Cool. Yes.
There are integration points with various chat op tools like Slack or HipChat for just reporting as well as the dashboard.
Not yet. We've got so a colleague of mine, Oliver, has written a whole bunch of IRC bots which are interrogating the REST API and reporting to IRC based on that. They're sitting out in the public as well. So we haven't, but there's not like an official sort of part of it.
Just create a UI or something.
Yeah, create a U-bot. Yeah, just touch on the API. We've got that all there, and because of that, we've kind of opened up the API to all that reporting and stuff. So, like staging is a fine example. There's literally a staging bot that every hour is like checking everything's fine, and then it just goes all red and starts screaming in the IRC channel. So we know exactly when we have to start looking at it, and we're not wasting time worrying about it. Good. Anything else? Any ideas? No? Great. Thank you very much.